Hi there, this is Will Patillo. This is the third in a four-part series on moving, scaling, and rotating the camera rig. Now our goal is to be able to scale the rig by pressing the grips on both hands simultaneously, and when the player moves their hands apart with the grips pressed, then everything around them will get bigger, or more accurately, the camera rig will get smaller, making the world appear to get bigger. And when they pull their hands together with both grips pressed together, then the camera rig will get bigger, making the world around them look smaller. We need to get the distance between the player's hands on this frame. Compare that with the distance between their hands on the last frame, and translate that change in distance into a change in scale. So start with getting the player's distance between their hands on this frame. I'll set up a variable, call it dist_cur, and that is going to equal their left hand lock dot position minus their right hand lock dot position and dot magnitude. So remember from the previous work we've done on this, we already know the player's left hand and right hand lock positions because we've assigned them to these transforms. If we take a look at the camera rig, we have their left hand lock is the left controller, right hand lock is the right controller. We're already getting whether they're gripping with either hand that's being passed in from the controller input script. So pretty much have all the information we need just from work we've done in previous tutorials. However, we're only using a floating point number, whereas these are vector 3's. So I put all this in parentheses and put in a dot magnitude to translate those two the difference between those two positions to a single number. All right, next, distance delta, or the change in distance from the last frame. So I'll put that comment up here. Is going to be our dist previous minus dist current. So that's the position that their hands were, the distance their hands were apart from each other last frame minus the distance their hands are apart from each other this frame, divided by transform dot local scale dot x. Now the importance of this division is that as the player gets bigger, then with the same physical motion of their hands in the real world space, it's going to translate to a bigger movement inside the virtual environment, which means as they get bigger, they'll scale up and down faster, and when they get smaller, their hand motions will have very little effect, and that's not good in either sense. So by dividing it, as they get bigger, this becomes a larger number in the divisor, which will shrink the effect of the distance delta, and conversely, when they're smaller, say a scale of 0.2 or 0.1, then it'll have the effect of multiplying this distance, and in both cases it smooths everything out. I'm using this as a .x because transform.local scale again is a vector 3, and all we need is a single number. Okay, so that gets the distance between the player's hands on the last frame. We still need to declare these variables, but I'll get to that in a moment. Next, translating that change in distance into a change in scale. So let's see, our scale change equals, I'll just write this first and then explain it next. 1 plus dist delta times scale multiplier times time dot delta time. Okay, so distance delta, that's the change in the distance between the hands. Whenever you're dealing with time in something that's, remember this is being called by an update function, it's good to multiply it by time dot delta time to just make the movements more uniform and not dependent on frame rate. And then lastly, this multiplying by scale multiplier is, when we run this, we might want to have the scaling happen faster or slower. And if we make this a public variable or at least a serialized field, then we can set it in the inspector or elsewhere in the program how fast this scaling actually happens. So it gives us a lot more control. And finally, this 1 plus this whole thing, because if we just had this and there, this is like a 0 there, then they would instantly shrink no matter how the player's hands move. Anyway, moving on. Okay. Next, forgot to mention this in the pseudocode, apply calculated change of scale to actually change the player's scale. That's an important step. And we'll do that by saying simply transform dot local scale times equals scale change. We've already computed this number, and we can just say transform.local scale because remember this script, rig control script, is attached to the camera rig, so we're able to just directly access this scale right here and modify it through this line. And then finally, we need to reset, actually I'll just put it up here, set the distance for the previous frame. Distance previous equals dist current. Save the distance between the player's hands for use next frame. Okay, so now let's getting a lot of red here, so let's declare some of our variables. So going to need some floats for dist cur, dist previous, and dist delta. Let's see, did I cover everything? No. And I also need another float for scale change. Okay. Oh, and then lastly, throw in a serialized field float scale multiplier. I'm using a serialized field here so that I can access it in the inspector window, assuming there's no errors. Yes, there it is. So here I can put something like, I don't know, say 50. You can experiment around with this number to see what gets the effect that you want. So one problem that we have right here with the script is, for most frames it's fine. We go through this and we set our previous distance at the end. But what about the first frame where the player first presses the grip buttons on both of their hands? Dist previous hasn't been set. So when we're subtracting dist previous minus dist cur, it's it's going to initialize just to 0. And that first time it's fine, but then when they try to scale again, it's going to save the distance between their hands like after they release the grip button. So we ran into that error in the last tutorial, so I'm just going to head it off right now and say if dist previous equals 0 f, then dist previous equals dist cur. And this is just a way to initialize dist previous, so we don't run into that error that we saw the last time with dist move where the camera would jump. Okay, and then yeah, else all the rest of this stuff. Let's keep our indents nice and tidy. Okay, and and then one other bit of error correction I'd like to add in here is after we've calculated our scale change, if scale change is greater than 1.1 or scale change is less than 0.9, then return. And I'm adding this because when I was testing this prior to putting this tutorial together, I was seeing some errors that would happen from just, the hand tracking can have problems and things can get off a little bit, and that could throw off the scaling. Like you'll suddenly see your size like jump up and then shrink down, or jitter and other things like that. So one way of taking those kind of like erroneous frames out is by just checking for when things happen that shouldn't happen. And again, this number, unless something's going really wrong, this is going to be very close to 0, which means this is going to be very close to 1. So if the number is considerably off from 1, by up by 0.1 or down by 0.1, then just skip this frame and don't bother scaling, because something went wrong and we want to just throw it out. And skipping a few frames in this is not going to make a big deal from the player's perspective. Okay, that I think may be enough to test this. So let's try it out. Let's see, I press the grips on the left and the right hand at once. I move my hands apart and the world gets bigger. Bring them together, it shrinks. I can do this multiple times. Something's getting a little in the way here. The basic effect of it's working. It's just multiple times is a bit of a problem. Well, one other thing that I want to change before I really delve too much into this error is give ourselves a little bit more control as the developer. And I'm going to put in a serialized field, float, max scale, and min scale. Weird things can happen when the player gets really, really small, and maybe also when they get really big. So, like if their scale like approaches 0, for example, I've seen. So preventing that from happening is a good thing to build in right off the bat. So gonna put in another if statement here. If scale change is greater than 1 and transform dot local scale dot x is less than max scale. Okay, so that is if they're getting bigger and they haven't exceeded the max scale, or scale change is less than 1, so that is they're getting smaller, and transform dot local scale dot x, and their size is greater than the min scale. Then all of this other stuff can happen. And by the way, we could also have, instead of returning out of this, put this in an else if and, skip the code that way. I like using return for cases where, it's just get out. Something's gone wrong, just leave this function. I think I find it a clear way to go. When it's more of just kind of a check in a more business as usual sort of thing, then that's when I just indent everything into an if statement. Let's see, now that, I don't see how that would affect the error that we were seeing, but I suppose I can just test it again. First, though, of course, I'm going to need to put in some values. So let's say for my max scale, I'm going to make it 10. For min scale, I'll go with 0.2. Those seem to be fairly safe values to work within. And maybe I'm also going to shrink my scale multiplier down to 20. Make this effect a little more subtle. Okay, let's see how it happens now. Controllers, and let's put it up here. Shrink. Oh, I know what it is. Okay. Silly mistake. Forgot one thing, although granted it's an easy thing to forget. This reset move. I need to set this dist previous equals 0f. So this way, when we set this to 0, then every subsequent times when the player presses the grip buttons to scale themselves, then this previous is just going to be dist current. It's going to be effectively ignored. This delta is going to be 0. There's not going to be any scaling for that frame, but it's just one frame, and as they continue to move their hands, then the scaling will happen the way it is supposed to. So with that line in place, let's test this again. Okay, get my hands, and I expand until I get to some maximum size, I think. Yeah, there. Now at a certain point, I can't get bigger anymore, and this is, plenty big, and if it's not enough, I could always just set that maximum scale to something bigger than 10. Likewise, I can shrink down. Make the world around me really big. And at a certain point, I can't anymore, which is fine. And again, if this is not enough, I can set field lower than 0.2, although I would be careful about it on the min side. Scale back. Alright, so everything looks like it is working. Now there's one more feature I'd like to implement. It works very well if you're standing on a surface, and say I get smaller, I'm still standing on the surface. And those blocks up there look like they're getting higher or lower up. Now I can see above it, and I can't see below it. It looks like it's below me. If I get smaller, it looks like it's above me. And that's fine for a context where you're earthbound, walking along the ground. But say the context of your application is you're like in a space type setting. There, when I change size, I don't want my feet to be in the same place. I want my center to be in the same place. Next thing I'm going to work on is having an option, which we'll just set as a boolean, we can tick or untick in the inspector, that raises or lowers the player's Y position based on their change in scale. At the end of this whole changing scale, I'm going to put in another if statement, and if they are, let's call it, say, use y offset on scale, because this is an optional feature. Then transform dot translate. So we don't need to move in the x-axis. We'll move in the y-axis by scale delta and 0. Right here, I can say their before scale equals transform.localScale.x. So we get their scale before the change, and then this is discur. Then their after scale equals, no, autocorrect, I don't want you to exist ever, transform.localScale.x. And these two numbers are not necessarily going to be the same, because say the player's is at 1, and then they shrink down a little bit because of scale change. Now it's going to be 0.9. So now after scale might be 0.9, and so even though this is happening in the same function call, the numbers, and they're being set to the same variable, it doesn't mean that they're going to end up being the same. Anyway, so that's after scale, and then scale delta equals before scale minus after scale. After scale. I just need some more floats. Float before scale, after scale, and scale delta. We'll also need, actually put this up here, serialize field, bool, use y offset on scale. That was what we were calling it. Okay, and now all the errors go away. So now if I, let's see, wait for that to show up. Okay, good. So if I leave that unticked, then it's going to work the same as before. And if I tick that box, and I run this, what you'll see is, as I scale up and down, my height doesn't change. Now I'm staying at the same position in space, and my feet appear to be, or where my feet would be, are off the ground. As I go the other way, get bigger, I stay the same. Actually, I'll make it clearer by putting myself right and face right and level with the blocks. So now, as I scale, and I wasn't really using the move very much, since my setter's staying in the same position, now this is up here. So this mode will be very useful if you're have asteroids or other things that shouldn't be changing position around you. Again, for a little bit of contrast, actually I'll just take that variable off, put this again around foot height, and now I'm kind of like earthbound again. All right, that is everything for getting a working with scale in the camera rig in Unity. Again, you can change how fast the scale multiplier works. I can say if I up this to 50, I can happen, let's see, a lot faster, which actually I kind of like 50. This is yeah, I recommend that's a good number. It's nice and satisfying motions there. But you can change that however you like, or make it something dynamic. You can play around with these maximum and minimum scales depending on what your needs are. Just make sure to test it to make sure there's no errors. You can use this Y offset or not depending on the context of your application. And yeah, that's all for now. Thanks for watching. If you would like direct access to the code for this project, there is a free public repository on GitHub, and I have linked to it in the description for this video below. If you have any questions, please feel free to ask them in the comment section. And if you enjoyed this video and like to see more like it, then don't forget to like and subscribe. Until next time, I'm Will Patillo, signing out.